Hello and welcome to our first lecture. This is Dr. Humston, Introduction to Chemistry, and we're going to be going through Essentials of General Organic and Biochemistry, third edition with Gwyn, and starting off Chapter 1, Matter, Energy, and Measurement. And we're going to be looking at Section 1 today, Matter and Energy. But first, I wanted to start with a quote from the beginning of this chapter, because remember, this is intended for future healthcare workers or current healthcare workers, typically future nurses. This book also gears towards those types of students. So that's the context of all this. And they say, if you are working in the healthcare field, you will take measurements routinely and perform calculations that are critical to the health of your patients, such as dosage calculations. Developing the skills learned in this chapter is a basic part of your training and also central to understanding chemistry. I wanted to give a quick look at a screenshot of a page. Okay, you're going to be spending a lot of time in this textbook, and you might be new to reading textbooks. Okay, and so I want to just point out some things that you can see as you go through this book. Notice a lot of words in bold. Okay, bold words are important terms, often followed by a definition. There will be like a list of all of these words at the end of the chapter, but you'll see them in the context right there. Notice core concepts often on the margin. Okay, those are basically important summaries of the important things that you just read in the text. All right, so you have to read the text, but then I would recommend going back and reading these core concepts. And if you can make sense of that, if you understand those, then that's good. If you still don't quite get it, go read the text again. Go back and forth between the core concepts, the text, maybe some practice problems. Okay, there's going to be figures, such as this one, that actually has chemical content to it, right? It's telling you more information about, um, well, in this case, solids, liquids, and gases. There's also going to be figures like this one, which is mostly just something to look at, right? It's not actually going to tell you something new, quite like this one, but read the caption. The caption might say something interesting. All right. I'm going to post, in addition to these slides, a PDF that I have found called How to Read a Science Text. Right, because it's different than reading like a novel, different than reading even like a popular science book. When you're reading a textbook with the goal of learning the material, this is a different approach. And so I'm going to post that, and I want you to go check that out when you're done with this lecture as well. Okay, let's get on to the first section, matter and energy. And remember we said on the first day, chemistry is the study of matter, changes in matter, and the energy associated with those changes. All right, so this section sounds like it's 2/3 of the course, right? Or more, right? Matter and energy. But this is just the beginning. We're going to basically get some definitions, some terms. We're going to make sure we have a good starting point, okay? But again, we said basically the chemistry is the study of everything, right? All the stuff around us that we can see, and even the stuff we cannot see, especially the stuff we cannot see, is matter, right? So with that in mind, let's jump to just a couple of words, what they mean. So matter has mass and takes up space. That's the definition of it. So like we said, pretty much everything in the physical world has matter, takes up space. A substance is a specific type of matter. Okay, we're getting a little more precise there. Substances can take states or state of matter, solid, liquid, gas. And we're going to be looking at different scales, different sizes, right? The atomic scale, the microscopic scale, and the macroscopic scale. So let's start with matter and states. Matter is found in three states, as we saw before: solid, liquid, gas. You're familiar with all these. They are observable macroscopic scale properties, right? So macroscopic means something that you can see. It's in the realm of humans. It's observable. Atomic scale, right? Like atoms, you can't see those. They're not observable to our eyes. But macroscopic things are. So thinking about your experience with solids, liquids, and gases, uh, let's try to characterize the volume and shape of these three states. So let's look at volume first, right? So let's imagine we have a solid. It could be a pile of small grains like this. It could just be a rock or something. If you were to have it in this vial and pour it onto the table, would the volume of the particles change or the volume of the rock change? And the great thing about these videos is you can pause it and think for yourself before you answer. So is it fixed volume? Is a solid have fixed volume or unfixed volume? Think for yourself, and then we're going to say it has a fixed volume, right? It doesn't change depending on the container. What about a liquid? If you have 12 ounces of a liquid in a can and you pour it out into the sink, you still have 12 ounces of liquid, right? It hasn't changed. It's just maybe shape has changed. We'll see. In a gas, if you have gas in a container and you open the lid, what happens to the volume of the gas? It expands to fill the space that it can. So the volume is unfixed. Okay? Now let's look at shape. If you have a solid, let's say a rock, and you move it from a jar to the table, the shape does not change. Once again, the shape is fixed. A liquid, though, right? If you pour out a liquid from your cup, it will change its shape. This is so it's unfixed. A lot of kids have a hard time with this. Um, if you have different sized glasses, like a tall, narrow glass and a short, fat glass, um, young kids will think the tall, narrow one has more, let's say, milk in it because it's taller. But all that happens is the liquid changes its shape to take up the container that it's in. So it's an unfixed shape. And gas. Gases, we said before, fill the space available to them, so it's also unfixed. So we have different combinations um, of volume and shape there. So the question is, why do these different states exist? Why do these properties of different states exist? What is causing them? And the answer, one that we will make often, is found when we look at the particles themselves or at what we would call the atomic scale. So the macroscopic properties that we see are a result in the way the particles interact with each other on the atomic scale. So if we could zoom in on our solid, we would see the particles arranged in a nice ordered structure and arrangement. They are interacting very closely and tightly with each other. They're well packed, highly interacting. They're not moving around very much. That explains some of the properties that we see of solids. If we look at a liquid, the particles are still interacting, but they are in a disordered arrangement. And for a gas, particles are far apart and they're not even interacting with each other at all. Okay, so they're just gonna try to like hit the corners, right? They're gonna just stay on the wall and not interact with each other. That's why they fill up the whole space available to them. Think of it like you're at a concert, okay? And the solid is like Everyone's sitting in their seats. Okay, they're still dancing. We would say actually they're vibrating. You could think like they're really excited. They really like the music, but they're sitting in their seat. They're vibrating closely by themselves in their own space, in a nice ordered way, right? The liquid is like a dance party, maybe even a mosh pit. Okay, the particles are tumbling over each other. They are interacting, but in a very disordered way. Okay, they're moving more than solids. Um, they're not moving very fast because there's a lot of other stuff in the way, a lot of other people, a lot of other particles, but they are a big mosh pit. And the gas particles, those are like loners, people just dancing wild and crazy all by themselves at a music festival on the lawn, right? They're not interacting with anyone else. They're just totally on their own. Um, and they're maybe even moving fast, moving all around. So that's one way to think about these three. Okay, let's take a break and answer a question. Select the correct statement concerning the atomic scale differences between solid and liquid, solid water and liquid water. So the nice thing here with these, you can pause it right now and answer for yourself and then come back and we'll answer together. So I will continue. A, in the solid state, particles of matter are close together, but in liquid state, they are very far apart and interact only during collisions. Very far apart and interact only during collisions sounds like a gas. So I'm going to cross that out. Particles of a solid vibrate, while particles of a liquid move randomly and tumble over one another. That sounds pretty good. I'm going to hold on to that one. C. A particle, or in a liquid, particles of matter are disordered but vibrate, while particles in a solid are ordered but move randomly. No, particles in a solid do not move randomly. And they vibrate, actually. And D, particles in a liquid move more rapidly than those of a solid. Well, they're not. B is the best answer, better than this one, I think, right? Particles in a liquid, they don't move rapidly at all. Gas particles move rapidly. Particles in a liquid just kind of tumble over each other. And so the answer is B. Particles of a solid vibrate, while particles in a liquid move randomly and tumble over one another. We'll do one more slide and then pause this and stop for part two. So I just wanted to reintroduce these definitions: macroscopic, microscopic, and atomic scale. Macroscopic is something that can be seen by the naked eye. Microscopic is something that can be seen but under a microscope. And the atomic scale cannot be seen with a light microscope. You need something like an electron microscope. So classify the following examples. Now I want you to just pause it and do this on your own. Okay? So pause, and then when you come back, we'll see the answers. Okay, and here they are. So a virus, atomic scale; red blood cell, microscopic scale; human body, macroscopic scale; a grain of sand, macroscopic; DNA, atomic; and a skin cell, microscopic. Okay, so in general, I'm going to try to keep each video to less than 15 minutes, and then, or 10 to 15, and we'll do 3 or 4 of them per like lecture day. So this one I'm going to stop and then continue with a part 2.